This is section 1.6, problems number 5 and number 17. They are related, of course. 17 asks you to use the same equation as number 5. We'll start with number 5. The equation that we're given is dw dt is equal to 1 minus w times the sine of w. And drawing a phase line requires us to find equilibrium values. Equilibrium. And that's nothing more than asking, well, when does the right-hand side, which we typically will refer to as a function of w, when is that function of w equal to 0? Well, it's going to be equal to 0 when w is 1, that's easy, or when the sine of w is 0. But that happens when w is equal to n pi, and n is any integer. Any integer. So if I were to make a little list of equilibrium values, it would have to include the list. I'd have minus 3 pi, minus 2 pi, pi, 0, here's our 1, and then just multiples of pi. So there's an infinite number of equilibrium values for this problem. To make a phase line, we're going to need to know the sign, the plus or minus sign, above and below each of these values. And so I'm going to make a little sign chart. I'm going to mark, I'll start here at minus 3 pi, minus 2 pi, pi, 0, pi, sorry, it's a minus pi, pi, 2 pi, and 3 pi. And the number 1 is about a third of the way, and so 1 is somewhere around here. I'm going to let you figure out and agree with me, but these are my equilibrium values. These are my places where the function is 0, and in between these values, I have to be either positive or negative. I can't change sign. But for example, and we'll take a look at the sine function, even though we're all comfortable with it. But the sine function is positive to pi, negative at 2 pi, and then positive again, and continuing. Here we are at pi, 2 pi, boom, boom, boom. And here's my sine function. Sorry about that. Okay. So between 0 and 1, between 0 and 1, my sine function is positive, and 1 minus w, w is less than 1, is positive, and so positive times positive lets me say it's positive through here. Between 1 and pi, Well, my sine function is still positive, but 1 minus w, when I'm bigger than 1 minus w is negative. So I have a negative times a positive, and that's going to be negative. When I'm in this region, between pi and 2 pi, the sine function is negative through here. 1 minus w, w is bigger than pi, w is in this region, so that's negative, this is negative, my sine function is negative, so I have a positive value through here, and then it's just going to alternate negative, positive. And same reasoning, it'll be negative through here, positive, negative. So that's what my sine chart looks like. I'm going to take this to the next slide and draw my phase line, and then answer question number 17, draw solutions. And here we go. Next slide. Okay, so starting where we left off, I'm going to recreate that sine chart, but I'm going to do it vertically this time. Well, I'll reproduce it here first. So what I just showed on the other page, I went from minus 3 pi, minus 2 pi, pi, 0, pi, keep leaving that off, that's a minus pi, positive pi, 2 pi, and 3 pi. And these are all my equilibrium values. This axis is the w axis. These are my equilibrium values. These are values of w that make f of w 0. The number 1 would be right here, and that's also an equilibrium value. And I just showed on the other page that in this region we are positive, then we're negative, then we're positive through here, negative, positive. We are negative here, positive, negative, positive. So a phase line reflecting that information, I'll let this be 0, pi, 2 pi, 3 pi, minus pi, minus 2 pi, minus 3 pi. And we don't have to go on forever because the pattern will repeat itself. These are my equilibrium values. I like to be able to classify them as sources or sinks. I need to include the value at 1 as well. Here's 1. That's an equilibrium value. Equilibrium value. Equilibrium value. Equilibrium value. Okay. Well, now I can come up to my sine chart, and I can look and see that, let's start at 0. When my values are smaller than 0, when I'm down here, when my values are smaller than 0, I see that I'm decreasing. I have a negative sign, and so I draw an arrow going down. When my values are slightly bigger than 0 but less than 1, I see I have a positive sign here. My values are increasing, and so I will draw an up arrow. I've got to squeeze it in there. Like that. So at 0, I would argue that I have a source, and so we'll continue like this. Above the value 1 in this region, when I'm between 1 and pi, I have a negative sign. Above 1, I have a negative sign. And so I draw an arrow going down, and now I'll just continue going up and going down. And the pattern continues. Here I'm going up, here I'm going down. Again, between minus 2 pi, minus 3 pi, negative sign here, and so I draw a downward arrow here. And I can identify sources and sinks very easily. This is a source. I'm not going to write it, but this is a source because the arrows are leaving it. Number 1 is a sink. The arrows are both approaching it. Pi is a source. 2 pi is a sink. 3 pi will be a source, and so on. In number 17, it asks you to use this information to sketch solutions. So let's mimic that axis. Let's take the 0 and draw the 0 right here. So now I'm on my time axis here. This is my p-axis, and again, let me mark my equilibrium values of 2 pi, pi. Here's the number 1. Here's 0. Here's minus pi. Here's minus 2 pi. And minus 3 pi. These are equilibrium values. If I were to start on one of these lines, I would stay on the line. Zero 2 is an equilibrium value. Minus pi is an equilibrium value. Minus 2 pi. Minus 3 pi. And they repeat. In question number 17, it says, sketch solutions that satisfy the following initial conditions. So for example, I'll use a different color. If I were at time 0, so this is my time axis here. If at time 0 I were at the value of negative 3/2, negative 1.5, well, pi is negative 3, so that would put me roughly around here. Knowing that that minus pi is an equilibrium value that is a sink, I can see that it's a sink. That means if I start above minus pi, I am drawn to minus pi, or I can just observe from my phase line that I'm going down. If I start here, I'm going down. So that's that one. If I start at at 1, then my solution curve will stay at 1 because 1 is an equilibrium value. If I start at 2, somewhere between here, bigger than 1 but less than pi, if I start here at 2, I look across and I see that my slopes are going down because the number 1 is a sink. And so if I start at 2, my slopes are negative and they approach the value of 1. If last one, if I start at negative 1, well, negative 1 is no different than, I'm sorry, not negative 1. If I start at 3, which is still less than pi, pi is 3.14, I'll use a different color. If I start here at 3, that's the number 3. It's less than pi. And remember, pi is a source. All solutions move away from pi. And so again, I would follow this curve. Again, they can't really touch, but they're both approaching the number 1. And that's the end. Thank you.